The most advanced artificial intelligence systems may never set foot on Earth. The future of AI doesn't lie hidden in some desert data center. It's unfolding in orbit, circling the globe silently, endlessly, thinking. That future is now in motion. On May 14, 2025, a Long March 2D rocket ignited the edge of the Gobi Desert sky. The world barely blinked, but on board were 12 satellites that could change everything. They were small, compact cubes of metal and wire, but within them was the birth of something unprecedented, an AI supercomputer constellation in space. It's called the Three-Body Computing Constellation, and it's being built by Chinese aerospace firm ADA Space and Zhejiang Lab, a government-backed research powerhouse. Together, they're launching an audacious project to place 2,800 AI satellites into orbit, each equipped with its own powerful onboard intelligence to form the world's first orbital cloud. Not a metaphorical cloud, a real one, circling the Earth. Computing, communicating, evolving. This isn't a tech demo. This is the future of global infrastructure, and it's already begun. Artificial intelligence today is voracious. It feeds on data, processing power, and electricity at scales our systems are struggling to provide. Major AI models require entire warehouses of graphics processors. Training GPT-level models can emit as much CO2 as multiple transatlantic flights. And those costs are rising, not falling. The problem isn't just power, it's physics. Traditional data centers face massive heat dissipation challenges. Cooling systems, which often draw more energy than the computation itself, are rapidly becoming unsustainable. Add to that the geopolitical risks of terrestrial infrastructure, cyber attacks, physical sabotage, blackouts, and it's clear, our current AI ecosystem is cracking at the seams. At an April 9, 2025 US congressional hearing, former Google CEO Eric Schmidt issued a stark warning. We're heading toward 29 gigawatts of new data center demand by 2027 and 67 more gigawatts by 2030. I've never seen industrial growth like this in my lifetime. So where does the solution lie? Space, ironically, solves many of Earth's biggest computational challenges. In orbit, cooling is free. The vacuum of space allows heat to radiate away with ease. Energy is abundant. Solar panels can draw direct sunlight without atmospheric loss. And latency in observing Earth systems, like wildfires, floods, or enemy troop movements, drops dramatically when you compute at the source. This is the promise of edge computing in orbit, and China is now pioneering it at scale. Rather than transmit massive volumes of raw data back to Earth for analysis, a process limited by satellite bandwidth and timing windows, these AI satellites will analyze the data in orbit, transmitting only final results. That means faster insights, lower energy usage, and a fraction of the cost. Each of the 12 satellites launched in May carries an AI brain, an 8 billion parameter model, capable of performing 744 tera operations per second. TOPS. For context, Microsoft's Copilot plus AI laptops max out at just 40 TOPS. These orbiters are nearly 20 times more powerful, and that's just the start. Together, the first 12 form a computing cluster already capable of 5 peta operations per second. And when the full fleet of 2,800 is deployed, China will have created an orbital computer capable of 1,000 peta operations per second, or 1 quintillion operations per second. The name of the constellation isn't an accident. It's an homage to both mathematics and imagination. In physics, the three-body problem is a famously chaotic equation, one that describes how 3 celestial objects move under the influence of gravity. It's unpredictable, non-linear, and practically unsolvable. In other words, it reflects the world we now live in. But the name also references one of China's most famous science fiction works, Liu Cixin's The Three-Body Problem, a trilogy that explores alien civilizations, astrophysical computation, and the survival of intelligence in a hostile universe. In Liu's world, orbit becomes a computing surface. Data flows in cosmic loops. Knowledge is survival. China is now building the first pieces of that vision. At the Beyond Expo in Macau on May 21st, Wang Jian, director of Zhejiang Lab, offered a glimpse into the ambition behind the project. It's a good time to think about how we can put AI into space, not just in your laptop or cell phone. Space has, again, become the frontier for us to think about what we can do in the next 10, 20 or 50 years. But this isn't just a national endeavor. Wang suggested the system may be open to international cooperation, allowing other countries and institutions to tap into the constellation's capabilities, creating what he called a global computing commons. That vision sounds utopian, but it also raises profound questions. If the supercomputers are in space, who owns them? Who controls their insights? What happens when orbital AI becomes smarter, faster, and more accessible than anything on Earth? The constellation functions like a neural network in orbit. Each satellite communicates with its neighbors via laser links, enabling high-bandwidth, low-latency data sharing. They don't just act individually, they learn collectively. They adapt. They delegate tasks. One of the current satellites is equipped with an X-ray polarization detector designed to study gamma-ray bursts, which are among the most violent events in the known universe. In this way, the system is already doing something no Earth-based computer could, thinking at the edge of space, about the edge of the universe. And this is just the beginning. While the United States and Europe have tested small-scale space-based computing, no one has deployed an operational AI constellation at this scale, until now. Eric Schmidt, now a major investor in relativity space, has discussed plans to launch orbital data centers in the coming decade. But China's constellation is already in orbit, already computing and already expanding. That gives Beijing a decisive early lead in orbital AI infrastructure, a lead with sweeping implications for climate modeling, defense, communication, cybersecurity, and economic influence. Imagine a wildfire breaking out in Siberia. In the past, satellites would observe it, store the data, wait for a downlink window, then transmit to ground teams. A delay of hours or even days. Now, with edge computing satellites, the AI identifies the fire immediately, analyzes wind and fuel patterns, projects growth curves, and sends actionable insights in seconds. Imagine an asteroid streaking past Earth, or a sudden burst of solar radiation. These satellites can detect the anomaly, compare it with past data, and send alerts autonomously, while also adjusting their own orbits and shielding parameters to protect their sensors. The satellites don't just see, they understand. As the network expands, we may one day reach a point where Earth-based data centers become legacy systems, slow, inefficient relics of a pre-orbital age. Instead of building supercomputers in deserts, we'll build them in constellations. Instead of uploading to the cloud, we'll upload to the stars. And once intelligence lives in orbit, it's only a matter of time before it expands beyond Earth. 12 satellites circle the planet now, but they are just scouts. Soon, thousands will rise, a thinking mesh around the Earth. They'll map our weather, predict our future, monitor our movements, and maybe they'll ask questions of their own, because this is no longer just a computing project. It's the dawn of an orbital intelligence, and we're watching it wake up. Subscribe to follow the true stories of science, technology, and the future we're building above our heads. The next frontier isn't out there. It's already online, and it's already in orbit.